Okay, let's keep going. So question 6, we want to graph these quadratic functions again. We want to identify vertex, intercepts, and line of symmetry. But those ones are written in the standard form. So we call the number before x squared A. We call the number before x B. We call the constant C. So if it's in a standard form, we'd like to identify those three numbers first. So write them down. Now, A decides the graph going upward or downward, right? Remember quadratic function, the graph, we only have two kinds. One is a downward parabola, the other is upward parabola. So the leading coefficient, A equals -1, that means we have downward parabola. So what A does to us? The C, in standard form, 0, C, in this case, 0, -A is a y-intercept. So -A, I have to draw this longer. Let's see, -A is approximately somewhere here. And this will be -4. So this point, 0, -A is y-intercept. And we also need to find the x-intercept. Remember how to find the x-intercept? We set the function to be 0. So basically we're seeing -x squared minus 4x minus 8 is set to be 0. So see, this is a quadratic equation. And we want to solve this quadratic equation. So let's multiply -1 on both sides, because we want to get rid of the negative sign in front of x squared. We have x squared plus 4x plus 8 equals to 0. We could use either method. We have factoring method, but this one won't work. Right? If we try to factor this equation is not able to be factored. We could use a quadratic formula, -b plus minus square root of b squared minus 4ac divided by 2a, or we can complete in squares. Since we're not so good with completing squares, oh, this is plus a. Let me try to use completing squares, okay. Completing squares, I'm going only to keep two terms with x on one side. So x squared plus 4x. Then I'm moving a to the other side. It becomes -8. So then I focus on the number before x, which is 4. So in my head, I'm thinking, what is 4 divided by 2? Well, it is 2, right? So that means I want to add 2 square and subtract 2 square on both sides. So I'm going to add 4 on the left-hand side. At the same time, I'm adding 4. So 2 squared is 4. Where does this 4 come from? This 4 comes from, I take the number before x, the coefficient of x, which is 4, I divide by 2, then I get 2. Then I square the 2, which is 4. So I add 4 on both sides of the equation. So why I do that? Because with this trinomial, x squared plus 4x plus 4 gives me a perfect square. The perfect square is x plus 2 parentheses squared. Then on the other side, I get -a plus 4, I get -4. Now I square root. Once I have perfect square on the left-hand side, I square root. When I square root on the right-hand side, I get a positive, negative, 2 values. I get a square root of -4, which is an imaginary number. So I get x plus 2, square root cancel each other. So I get plus minus 2 values of 2i. right? Imaginary number. So now I move positive 2 from the left-hand side to the right-hand side. Solve for x. I get -2 plus 2i and the -2 minus 2i. Two complex solutions. The complex solutions. Now, one more thing I need to do is line of symmetry. Remember, line of symmetry, we have the x value equals to -b over 2a. That's why in our case, our b is -4. So -4 become +4 divided by 2 times a. 2 times -1 is -2. 4 divided by -2 and -2. So the x value is -2. Once I have the x value, I can find the function value or the y value by input -2 for x. So the -2 squared minus 4 times -2 and minus 8. What do I get? -2 squared is 4, but I have negative sign up front, so I get -4. -4 times -2 is +8, then minus 8. So a minus a equals 0, so I get -4. So my vortex, so this gives me my vortex. X value is -2, and the y value is -4. Okay, let's graph this vortex. Let's use blue color. So x value is -2, somewhere here, -2. -4 somewhere here. So this is my vortex. So the before I draw those two hands down was too high. 2 hands down has to be here. Okay. Then remember we have a y-intercept. Our y-intercept is 0, -8. So this point is our y-intercept. That means my graph has to go through this y-intercept. So the hands down are here. Okay. And where's the line of symmetry? Line of symmetry goes through my vortex. So it's this one. What's the name of the line of symmetry? The x value equals to the vortex x value, which is -2. So x equals -2 is a line of symmetry. Because on this vertical line, every point has x value to be -1, -2. So the vertical line has a name x equals to -2. Okay, I have the symmetry there, so now I can finish the other side. I tried to draw symmetric, right? So erase this, right? So that's the graph. You see this graph doesn't cross x-axis because our x-axis is here. This is our y-axis. So whenever we have a complex solutions, the graph of the function goes away from x-axis because the solution is complex. It's not a real solution. If it were real solutions, it will cross x-axis. Because it's a complex solution, so it goes away from x-axis. We either have, so this one is downward parabola. So we may have upward parabola like this, also going away from x-axis. That's when we have complex solutions for the x-intercepts, or for the equation when the function equals to 0. Okay, now let's see B. B, we do the same thing. Let's identify A, B, C. A is the number before x squared, B is the number before x, and C is the constant. Once we have this, we can, so in standard form, we can tell y-intercept right away because it's 0, C. Therefore, 0, -4 is our y-intercept. Well, x-intercept takes a little bit of effort. X-intercept means we don't know x value, but we know y value is 0. That's why we set function to be 0. We have x squared plus 2x minus 4 equals to 0. Set the function to be 0. Then we'll try to solve this quadratic equation. First, we see this is not factorable. And then maybe we're completing squares. Or you can always use quadratic formula. Okay. Completing squares, I'm going to do x squared plus 2x, leave on the left-hand side, move -4 to the other side. I write it as x squared plus 2x equals to 4. Maybe I leave a little bit of space. So now I want to completing squares. I'm thinking about them. Let me change my color. The coefficient of x, which is 2. I'm going to divide 2 from this 2, I get 1. I'm going to add 1 squared. 1 squared is 1. So I'm adding 1 on both sides. Then the left-hand side becomes a perfect square. And that has parentheses. X plus 1 squared equals to 4 plus 1, that's 5. So I'm in a perfect situation. I can square root both sides because left-hand side I have a perfect square. So I'm going to square root. When I square root, I get a positive -2 values on the right-hand side. So I have x plus 1 equals to plus 4 minus square root of 5. Okay, then I move this 1 from left-hand side to the right-hand side. So my two solutions is -1 plus square root of 5 and -1 minus square root of 5. Two irrational solutions. Complex solutions come in pairs, irrational solutions come in pair for this equation. So what are those two? Those two are our x-intercepts. So what's left? So we need to find a line of symmetry. Or vertex. Because we know once we find a vertex, we can find the line of symmetry. So x value, the vertex x value equals to -b/2a. In this case, b is 2, so get -2. Divided by 2a, a is 1, so divided by 2, we get -1. So the x value is -1. And we want to find the function value, which is f of -1. So plug in -1 for x. So the first term is x squared, we get -1 squared. And then plus 2 times x, which is -1. Then minus 4. -1 squared is 1. Then 2 times -1 is -2. Then minus 4. So we get a 1 minus 6, which is -5. All right, so that's so we found our intercept. Our intercept is x value is -1, and function value is -5. Once we have our vertex, we can also draw our line of symmetry. So that's our x-axis. This is our y-axis. Let's draw a couple points. Let's use blue color. 0, -4 is our y-intercept. Let's see -4 is here. That's our y-intercept. X-intercept is a little bit difficult, so I'm going to leave it for now. So we have y-intercept. Now line of symmetry. We have this vertex. Line of symmetry is at x equals to -1. So let's see -1 is here. Because this is -4, so -2, okay. Well, you know, x-axis and y-axis, the increment doesn't have to be the same, all right? So let's say the x for x, -1 is here. So let me draw. So our line of symmetry is this vertical line. And the name, so we need to give a name, all right, x equals -1. So in this case, we should be able to tell, talk to people, say, oh, what is the line of symmetry? That's x equals -1. It's not a -1. When you see -1, you're missing an important point. -1 is what? So you'll see, what is the line of symmetry? It is x equals to -1, because in two-dimensional world, x equals to -1 represents a vertical line. Okay, now we have a vertex, which is -1, -5, which is on this line of symmetry. So this point is -4, -5. We can just draw a little bit lower. Let's see, this is, oops, -5. So this point is, x value is -1, y value is -5. Right, that's our vertex. And then we know our graph has to cross our y-intercept. So it must go this way. Okay. Then we have this line of symmetry. We just draw the other half. We try to draw, with a perfect symmetry. Symmetry means you can fold the right half to the left half, they're overlapping. So what do? We're going to write down this as this one. The x value is -1. Oh no, wrong. It's a smaller one. It's 1 minus -1. Oh, I'm missing -1 here too. It's -1 minus the square root of 5. Okay. That's the x value for this one. Then on this side, that's -1. That's this one. -1 plus square root of 5, comma 0, of course. The y value is 0. Okay, that's it for B. Let's go to the next one. Let's see C and D. First, we want to identify A, B, C. A equals to 1, B also equals to 1, and C equals to -3/4, a fraction. So we may find a line of symmetry first. Oh, y-intercept is obvious. Let's write down y-intercept. So y-intercept is x value is always 0, and y value is C -3/4. And let's find x-intercept. X-intercept again is x squared plus x -3/4 equals 0. But I'm going to move -3/4 to the other side. So I get equals to 3/4. I'm going to leave some space. Now, what's the number before x, which is 1? 1 divided by 2, which is half. So I'm going to add half square on both sides. I'm adding half square, which is quarter. I'm adding a quarter on the left-hand side. I'm adding a quarter on the right-hand side. In this case, I'm making a complete. In this case, I completed the square with these three numbers, these three members. So I read as x plus half squared equals to 3/4 plus 1/4. That's 4/4, which is just 1. So I'm in the perfect condition to square root because I have perfect square on the left-hand side. So a square root, whenever I square root, I got a plus -2 values on my right-hand side. So I got x plus half equals to plus, well, what's the square root of 1? Square root of 1 is 1. 1 and making 1. So I move half to the other side. I get x equals to 1 minus half, that's half. -1 minus half, that's 3 halves. -3 halves. So 2 rational solutions. That means in reality, x squared plus x minus 3/4 can be factored. Okay. So I have two x-intercepts, half comma 0, -3 over 2 comma 0. Now let's graph. Oh, we want to find our vertex. So this is our x-axis and the y-axis. Let's mark our y-intercept with 0, -3 over 4. Let's see it's somewhere here. Okay, that's -3 over 4. And the x value is 0, y value is -3 over 4. And our x-intercept is a half comma 0. Half comma 0. Let's see this half for x-axis. Okay, which you should, if you do it, because it's so difficult for me using my fingers and writing on the mouse track. For you need to mark those numbers, mark those points with a number to tell people your increment. But for me, I'm going to skip that. So I have half comma 0 as x-intercept. Then I have -3 halves. So this is a half. This will be 1. -3 half will be somewhere here. This is my another x. So I have a y-intercept and 2 x-intercept. Now let's find our vertex. Vertex x value equals -b over 2a. What is our b? Our b is 1, so -1 over 2 times a. A is 1, so there's a 2. So it's -1/2. So x value is -1/2. Then we find the function value. We plug in -1/2 for x value. We evaluate. Half of -1/2 equals to x squared, which is -1/2 squared. We get 1/4 plus -1/2 minus 3/4. And that equals to, well, minus quarter, no, a quarter minus 3/4, we get -2 over 4. -2 over 4 is -1/2. So -1/2, that's -1. Okay, so our vertex is -1/2 and 1. Well, x value is -1/2 is somewhere here. And so that's our line of symmetry, actually. Let's graph that line of symmetry over there. X equals to -1/2. It's our line of symmetry. For vertex, x value is -1/2, and the y value is -1. The function value is -1. So x equals -1/2 and y equals -1, because I remember this is a half, right? Oh, that's 3/4. So one more, 4, there'll be 1 somewhere, a little more, so -1. Oh, I'm sorry, I marked the wrong place. I should mark here on the line of symmetry. Okay, great. You see our A is positive, so I have upward parabola. So I just go from the vertex, cross my y-intercept, and then cross my x-intercept. So that's my graph for C. Now let's see D. D, we identify A, B, C. Let me erase this. I need space. A equals to -2. B equals to -1. And C equals to 10. Is this factorable? 2 times 2, 4, 5. Yes. So this can be factored. So let's factor this. I'm going to, because I need to draw my graph on the side, so I'm going to write on the top of this. So how do I think about this? First, I put a negative sign outside, okay? I put a negative sign outside. Let's see, so basically factor out the -1 and 2x squared plus x minus 10 inside the parentheses. So I'm going to factor this. Factor b, I keep the negative sign. I'm going to factor b because I want to get 4x for the middle term. I want to get positive 4x, negative 5x. Then there will be add up to be negative 1x. So I need my 2 times 2. So what I'm going to do is, if I need to multiply those two, I need to put them in the separate parentheses. I want 5 to be negative, so I do 2x minus 5. Then x plus 2. Okay, you see in this case, 2x times x squared, I have negative sign, I still get negative 2x squared. Then negative 5 times 2, negative 10, negative 10 become positive 10. So how do I get a middle term? Middle term, I see I have negative 5x and positive 4x. In bingo, that adds up to be negative 1x. So this can be factored. So when I solve for x-intercepts, that's pretty easy. It's set up to be 0. So I get 2 intercepts. 2x minus 5 can be 0. And x plus 2 can be 0. So I get two solutions. X equals to 5 over 2 or negative 2. So I have two x-intercepts, right? 5 over 2 comma 0, negative 2 comma 0. So what else I need? I need line of symmetry. Right? X equals to negative b over 2a. Or what is b? B is a negative 1. Negative 1 becomes positive 1 over 2a. 2 times negative 2, negative 4. So we get a negative 1/4. So the line of symmetry is x equals to a negative 1/4. So we know the vertex is on the line of symmetry. So how do we find the function value? Plug it in again. So plug in negative 1/4 for x value. Then we get negative 2 times negative 1/4 squared, which is 1 over 16. Then plus x is a negative 1/4. Plus minus means it's a minus. Then lastly, we have minus 3/4, minus 3/4. We simplify this, we get negative 2 times 1 over 16, that's negative 1/8. Then negative 1 over 4 minus 3 over 4, that's minus 4 over 4, which is minus 1. If we want to simplify this number, we get a negative 9 over 8. Negative 9 over 8. So our vertex is negative 1/4. And the function value is negative 9 over 8. Okay, now with all this information, we can draw x-axis, y-axis. Now, let's mark our y-intercept. The y-intercept is obvious. It's just 0, 10. Let's see, 10 is somewhere here. So our graph will go through this point. And then we have two x-intercepts, 5 over 2 and negative 2. Let's see, this negative 1, this is negative 2. So here I have one x-intercept, then 5 over 2, which is 2.5. 2.5. Right. Okay, a little bit bigger than the other side. So have this one. So we see Hold on, I think I marked something wrong. Oh yes, because we have downward parabola, because our A is -half. I was looking at C. We have downward parabola. Right? And our x-intercept is a -1/4, which is very close here. And the -9/8. Basically -1 minus 1/8. So that's 10. So somewhere here, our vertex. X value is -1/4, and the y value is -9/8. I think I made some mistakes because the vertex cannot be lower than the y-intercept. The y-intercept is 0, 10 already marked over there. So the vertex has to be higher than it. Let's see, x equals to -b/8. Yeah, that's right. -1/4 is right. So -1/4, then we have -2 times 1/4 square, which is 1/16. That simplifies to be -1/8. Then I have minus x. X is just a -1/4. Minus negative become plus. Oh, minus negative become plus. This is a plus. I've made a mistake. Then plus 10, because I was doing D. Sorry, I'm a little bit sleepy. Plus 10. Now it looks right. Right. So 1/4 minus 1/8, that's 1/8. So this is 10, 1/8. This is not right. So it's 10, 1/8. 10 plus 1/8. It has to be taller than the y-intercept to make sense. Or -1/4 is very small. So you see now it has to go cross y-intercept, then come down to cross x-intercept. So this how, let me draw a line of symmetry. Line of symmetry is on this -1/4. Right, see this line is called x equals to -1/4. And then I could draw the other half of the graph. The other half graph is symmetric with the one I already have. So I'm trying my best to draw symmetrically, not so good. So this is a graph of D. It's a downward parabola. Okay, now we finished graphing quadratic functions. We're going to life applications. So this is question 7. I want to solve these problems. Let me make this a little bit smaller so you can see the whole thing. Okay, the first question is the sum of two numbers is 24. Let me grab my pen. The sum of two numbers is 24. So find the number if their product is to be maximum. All right, how do we use quadratic function to model this? Let's call, I have two numbers, right? So sum is 24, that means x plus y equals to 24. Because I have two numbers, I call one x, I call the other one y. X sum, x plus y equals 24. Then, because I'm looking for the product, right? So I'm thinking x times y. Well, if x plus y equals 24, that means y, let me maybe write it one more time. That means y equals to 24 minus x. So when I think about the product of x and y, that's x times y, I'm going to substitute y into 24 minus x. That gives me 24x minus x squared. Minus squared. If I think this as a function, if I think about the product as a function, I can think, okay, if I have to make a model of it, I'm thinking the model is f of x equals to 24x minus x squared, which is a negative x squared, because I want to write them in order, plus 24x. A quadratic function, right? So you see, I have made a quadratic function out of this. Now I'm I'm looking for the maximum value. Think about the graph of this function. The leading coefficient is -1. So we have a downward parabola. Downward parabola, the vertex is the maximum. So which means I need to find out the value of the vertex. So how do I find out the vertex? X value equals -b over 2a. Okay. What is our b? Our b is 24. So the -24 divided by a, divided by 2a, 2 times a is -1. And -2. -24 divided by -2, get a +12. So the x value is 12. And what about the y value? The value is f of 12. Basically, the y value for the x. We have -12 squares, 144. Then, oh, you know what? Let's not multiply together. So I have 12 times 12 squared. So let's just write down 12 squared. Then plus 24 times 12. Right? So -12 squared is 12 times 12. Then I see common factor of 12. That means I can factor out the common factor. 12. Then the first term gives me -12, left with -12. And the second term, I have 24. You may use calculator, okay? And then I have 12 times 24 minus 12, that's 12. I have 12 times 12, which is 144. So how do we answer the question? We don't need to graph. It said, find the numbers if their product is to be maximum. Do you see? I have found the product to be maximum. The vertex, when x value is 12, the maximum product is 144. Right? So if x is 12, let's go back. If x is 12, do we see y is also 12? Because y equals 24 minus 12. Yes, we have found the two numbers. Both are 12. I hope this makes sense to you. If not, we still have a review class when exam 4 is coming along. So I can explain to you face to face, okay? Now let's see B. So understand the question is very important because this is live application. But then to see which model, which function fits into this live application is needs us to be good at reading in English and also think about the functions we have learned. So B is the number of items a company sells is often a function of the item's price. Okay. It says the number of items, so how many, the quantity. It's a function of its price. It basically depends on its price. The revenue a company receives from selling bikes at a price P is modeled by the function. So this is revenue function. Okay, revenue function depends on the price. It's a downward parabola, -2.5 p squared plus 500p. The number before p squared is negative, so we're imagining a downward parabola. So we said, what price will maximize the revenue? Yes, downward parabola, we always have the vertex to be maximum. Maximum means the function value to be maximum or the y value to be maximum. It's not talking about the x value, talking about the y value. All right, so which means we just need to find this vertex. Right? X again, x equals to -b over 2a. What's our b? 500. The -500 depends on 2 times 8. 2 times negative 2.5, that's negative 5. So negative 500 divided by negative 5, that's 100. Okay, so let's go back to the question. Do we need to find the y value or the function value for, not x, right, p? Our variable in this case uses p, not x. So p equals to 100. So this is saying when the atoms is $100 each, and they get the most money, okay, the revenue is the maximum. So the question is asking what price, right, will maximize the revenue? Well, if they sell atom $100 each, so this price, $100, will maximize the revenue. Let's see C. Suppose you want to frame a collage of pictures. You have 9 feet of a strip of wood for the frame. What dimension of frame will give you the maximum area? What is the maximum area? All right. So we have this long piece of wood. Somehow we want to cut, right? Cut. Then to make a frame. Frame usually is a rectangle. All right. Even this question didn't say it, but we can imagine. Well, you know, picture frame have all different kinds, but maybe she should put a rectangular frame. A rectangular frame. So rectangular frame will have length, will have width, and then we want to talk about the area. The area is length times width. Right? And this one give us the relationship between the length and the width, because we need 2 length and 2 width to make the picture frame. That means 2 of L plus W equals to 9. Then to form the area is L times W, right? What does this give us? 2 times L plus W equals 9. We're dealing with the fractions. That means L plus W equals 9 over 2. That means, let me rewrite, let me type in here. That means L equals to 9 over 2 minus W. Oops. Because L plus W equals 9 over 2. So L equals 9 over 2 minus W. Now talking about the area, I can form an area function. Let's call it A. A depends on W because we can substitute L. The area equals W times the length. The length is 9 over 2 minus W. You see we have formed the function. And this function is negative W squared, which is downward parabola already, plus 9 over 2 W. Downward parabola, right? Because the number is negative 1 in front of W squared. So the question is asking what dimensions of the frame? So we need to find the length and the width. When the maximum of the area. Again, the vertex. How do we find out the vertex? W equals to negative B over 2A. Well, B is 9 over 2. So negative 9 over 2. Then divided by, divided by 2 times negative 1. Divided by negative 2. We have 3 layers of division. That means we just multiply the lower layers with the negative 4. The negative 9 over negative 4 will both be negative. Just turn it to be positive. So change. Oops, delete the negative sign. So W equals to 9 over 4. Then what about L? L equals 9 over 2 minus W. So that is also 9 over 4. L also equals to 9 over 4. Then the second question is, what is the maximum area? Or is it multiply? When you have length, when you have a width, you multiply those two quantities. So that's 81 divided by 16. So that's the maximum area. 9 over 4 times 9 over 4 is 81 divided by 16. Right here. Maximum area. 9 times 9, 81 divided by 4 times 4, 16. Okay, that's for C. Now let's see D. Paul needs to use 60 meters of fencing to enclose a rectangular garden, one side of which will be against the side of a house, which means one side doesn't need the fence. So just imagine we have a rectangular region, but this side goes along the house, doesn't need the fencing. We only have the fencing 3 sides. So let's call this L. Let's call this W. So basically, 60 equals to 2W plus 1L. Right? So 2W or 2 width plus 1 length equals to 60 meters. 60 meters basically is all the fencing for the 3 sides. So in this case, again, we could see L equals to 60 minus 2W. Right? Because later on, I need to use L in terms of a W. So now the question is asking, what dimensions of the garden will guarantee a maximum area? Again, the area. So I want to form a function f of W equals W times L. So the L is 60 minus 2W. Again, you see that the downward parabola again. Oops. Missing something. So 60 times W, this is 60W positive, negative 2W times W, that's negative 2W squared. We already seen a downward parabola. Right? So we want to find the maximum area, the maximum function value, the maximum f, such f. What is it? It's a vertex. The vertex. The vertex has an x value. The vertex has x value equals to negative b over 2a. What's our b? B is 0. Right? B is 0. Excuse me. Okay, I have a negative 2W. Oh, hold on. I made a mistake. W, how can I be 0? So x equals to negative b, which is negative 60. Negative 60 divided by, so negative b, which is negative 60, divided by 2a, 2 times negative 2, which is negative 4. Negative divided by negative, positive, so that is 60 divided by 4. Then it's 15, right? So it's 15. So the maximum area is 15. No, it's not. I'm really sleepy. I'm seeing nonsense. So that's a W. That's W value. Okay. So W, the variable W equals to 60 divided by 4. You know what? I'm going to erase this. Too much. Okay, let's restart. So I have 60 meters. So one way I can form my equation of 2W plus L equals to 60. In that case, I can rewrite my L as 60 minus 2W. Talking about area, I can form a function in terms of W, which is W times L. But then what is the L? I want L to be the representation of W. L equals to 60 minus 2W. This is. Then I distribute W at negative 2W squared plus 60W. So that's my function. That's my function. That's my function. F of W equals to over 2W squared plus 60W, which is a downward parabola. So the maximum will be the vortex. So W equals to negative 2B, negative B, which is negative 60, divided by 2A. A is negative 1. A is negative 2. So 2 times negative 2, that's negative 4. Negative 60 divided by negative 4, that's positive. 60 divided by 4, that's 15. Okay, so W equals to 15. L equals to 60 minus 2W. Well, 2W is 2 times 5, 15, which is 30. 60 minus 30, which is 30. What's the maximum area? Maximum area is 15 times 30. Maximum area. Yes. So W is 15. L is 30. So multiply those two for rectangular. 3 times 15, 45. But you don't have a 0. It's just 450. 450 is the maximum area. And the length is 30. The width is 15. Okay, I'm so sorry. I'm feeling so sleepy here. Okay, let's see E. Let's finish this. Let's finish E and F. So E is seen above through vertically upward from the ground with an initial velocity of 32 feet per second. And the formula for its height is given by this. Imagine you toss a ball to your friend. That forms the trajectory of the ball would be a downward parabola, right? You see the coefficient before t squared is negative, so it's downward parabola. What is the maximum height reached by the ball? So we want to find h of certain t has the highest value because this is a downward parabola. What's the highest value? Again, the vortex. So let's find the vortex. So in this case, the variable t. So the t equals to negative b over 2a. For negative, b is 32, so that's negative 32. Divided by 2 times a is negative 16. 2 times negative 16, that's also negative 32. So this one's equals 1. Because we have negative 32 divided by negative 32. So t is 1. Then we plug in for h of 1 to get the maximum height. So h of 1 equals to negative 16 times 1 squared, which is 1, plus 32 times 1, which is 32. 32 minus 16, which is 16. Okay. So what is the maximum height reached by the ball? It says 16 feet. Okay, let's see F. The height h in meters above ground of a projectile at any time t in seconds after the launch is defined by the function negative on the downward parabola again because the number before t squared is negative. Find the maximum height of the projectile. It has to be downward parabola. Otherwise, we won't be able to find the maximum because the two branches keeps going up or keeps going down. Okay, again, we need to find our P, the vertex. The vertex T equals negative B over 2A, which means the number before 48 was a negative 48. Divided by 2, 2 times negative 4 is negative 8. Negative divided by negative become positive. 48 divided by 8, 6. Right. So in 6 hours, the ball will reach its highest point. But the question is asking find the maximum height of the projectile. So what is the maximum height? Which is h of 6. So we just plug into the function. We have negative 4 times 6 squared, which is 36, plus 48 times 6 plus 3. Okay, so I'm closing off here. So negative 4 times 36 plus 48 times 6 plus 3, right? So negative 4 times 36, what do we get? We get a negative number, 4 times 6, 24. Then that's 120, so 144. Then plus 48 times 6, 6 times 8, 48. So 48, 288 plus 3. So 288 minus 144, that's 144. 144 plus 3, that's 147. So the maximum height is 147. And when the ball was tossed, when it's above ground for 6 seconds. Okay, I'm going to take a break from here. So that finishes question 7. And next one, we're going to start with 8.